Today I'm going to teach you how to use shape optimization to create a body which uses the least amount of material while still maintaining great structural rigidity. So for instance here I have this table that I've designed, and what I'm going to do is use shape optimization to create the second leg here. For what we need to do first is cut out an area where our new panel will go. For instance, something like that. To create a sketch on the bottom panel, and use the extrude tool to cut out the space here. Since this is a 10 mil thick panel, I'm going to go 5 millimeters up and 5 millimeters down. Now what we need to do is create a new body by using the extrude tool as well. You need to make sure that the operation here is new body, otherwise it'll join these bodies together, which we don't want. Once you've done that, select, and you should have your new panel here. Now you need to delete or remove these panels here. We can undo that using the slider here, so it should be fine. And we need to go into simulation. Delete this one here. What we need to do here is use the shape optimization test here, and just use this thing here. So what we need to do is add the loads and the constraints. So the loads are where the force is going to be coming down from. Since this is a table, we'll assume all the forces coming down from here. The value for the force doesn't matter, so just put something like 100 newtons. Next, what we need to do is do the physical constraints, where the table will be mounted. So for instance, we're going to say it's going to be mounted to the bottom here. So put the physical constraint there. Last thing we need to do is add preserve regions. We'll want to have all the shapes saved. So for this example, we'll have to have the first 5 millimeters of the box preserved, so that it'll fit into the new into the hole that we made. Like that. Right, now make sure that the tick up here is green, the pre-check tick. It'll say everything's done, and we can hit solve. You'll have to do this on cloud, so it won't matter if you have a powerful computer or not. And solve the study. Study 1. Now this will run the study on Adobe's personal cloud computing software. Right, now the simulation is complete. We can click close, and we can see it's created a shape for us. What we can do is add or remove from the shape using the load prompt tool here. What I should have done initially is put a line of symmetry. So for instance, I can do more constraints. Symmetry plane here. So this will allow us to create a symmetrical object this time. We run the simulation again. Right, now that the simulation is done again, we can see this time it created a more symmetrical. We can choose the thickness of the actual object by using the slider here. So let's say around the middle. This gives us a good shape. What you do now is click promote, and then you add the mesh to design workspace. Click OK, and the mesh should pop up here. From now you can remove the body here, and undo the operations to remove your 3 bodies. Now you can see we have the optimized shape here, and we can use the edit tool here to simplify and change it and make it look better, which I'll do real quick. Alright, now we can see I've done a simplified mesh here, which looks pretty nice, I think. And that's how you use generative shape optimization to create bodies which have the same structural rigidity but using it as material. Thank you.